welcome. Today let's try to solve another Leetcode problem, 871, minimum number of refueling stops. So basically we are giving a target. This means the maximum, the longest distance we can reach. For example, the target is 1. So I'm going to use the example 3 to explain it because there are more stations inside the stations array. So if we have a target 100, it means we want to reach this target. Now let me copy the stations array to explain it. And for the start field, it is 10. So from the beginning, we are at the position 0. We want to reach the position target, which is 100. But we have a start field 10. So this 10 means we can go to the position 10. It means just if we have the field of 10, we can reach at the position from 0 to 10. Now we want to check if we can go to the target, but we need to calculate the minimum refueling. I think we call it refill. We want to calculate the minimum number of refueling stops the car must take in order to reach the destination. Otherwise, we're going to return -1. So let's try to use this example. So from the beginning, we are at 10. So this means I can reach to this position. Because this is 10. So this is the index 0 for the subarray. This index 0 means the position. For my start field, I can reach 10. And this 60 means how much gas I can refill. So this means I can get 60. But for my tank, I can refill as much as I like. There's no limitations. Even it is 1000, I can still refill it. So this is actually the question described. So we start with the 10 liters of fuel. So we drive to position 10. Expecting 10 liters of fuel. So from here, we spend 10 liters of fuel. So we refill from 0 to 60. Because up to here, when we go to this position, we already spend that 10 of fuel, so it is 0. And then we can have 60 because from here we can refill. So we get 60 liters of gas. Then we drive from position 10 to position 60. Why? Because we have 60 liters of gas, so we can drive from 10 to 60. So we spend 50 liters, so there's still 10 liters left, right? But we can still refill from the position 60. So how much we can refill? We can refill 40. So 10 plus 40, it is 50, right? So it is 50. So we then drive to and reach the target. So 60 plus 50, it is 110. It is more than 100. It means we can reach the target, right? So this is what the question said. So if you refill, for example, at the first position, from here, you spend 10 and you refill, you get 70. So, but our target is 100. It means you cannot reach it, but you've already spent 1 time for refill. So maybe you go to the second position, you spend 10. From 10 to 20, you spend 10. So what field did you left? It is 50. 50 plus 30, it is 80. So from here, you got 80 liters of gas, but you are at position 20. So 20 plus 80, it means you can reach the target. This is also another way to reach the target. So it is also the minimum times we need to refill. So this is refill. So this is also 2. But for this problem, actually, we are going to calculate the minimum of refill. So how should we calculate it? Yeah, so this is the idea from greedy and regret. So from beginning, we can make a plan. So yeah, I know there's some oil, some gas in my car. Yeah, I don't, but I also know all positions of the gas station, and I also know at each position how much gas I can refuel. Yeah, according to this strategy, so this is the greedy idea. So why not we refuel at the station which has the maximum of the gas? Yeah, for example, this 60 is the maximum. Yeah, we refill here because here is 30. Yeah, because even we refill, we didn't reduce our oils. It doesn't mean if we refill, we just take some gas out from the tank. It doesn't mean that. So this means we can use the greedy idea. We first use this start fill to check how many numbers of stations we can go through. So for example, the first one, it is a 10. So it means we can only go to the first station. So if the start fill, for example, is 30, so it means we can go to the first station, the second station, and the third station. Yeah. Can we go to the next station? No, because we only have 30 of start fill. It means we can only go to 3 positions. We cannot go to the 4th position. So what should we do? Yeah. So what should we do? We cannot go forward. Yeah, but we can make a refill. Which station should we refill? Yeah, we should always refill at the maximum of the gas. It is 60. Yeah. Yeah, because even if we go here, for example, we have 10 plus 60, it is 70. Yeah. If we refill at 20, yeah. First of all, we cannot refill at 20, even if we can. For example, if the start fill is 20, if we refill at 20, so we spend 20 and refill 30, so we get 30 at this position. Yeah. So what is the maximum distance we can go? So 30 plus 20, it is 50. But what if we start at the first position? It is 60. So we have 20 of start fill. Now 20 plus 60, it is 80. It means the maximum distance, it is more than 50. Yeah. So this is the greedy idea to solve the problem. Actually, it is only this idea. So the idea is the greedy, but it is called regret greedy. So from the beginning, we are just need to check how many stations we can go through with this start fill. Yeah, and we just need to choose the maximum liters of the fuel to refill. Yeah, we don't want to refill at the minimum or other numbers. We just want to choose the maximum because only choose this one, it means we can go to the longest distance. Yeah, because more gas means more distance. Yeah, more gas means longer distance. Yeah. Now let me try to solve it. So I'm gonna prepare a result. So this result is my return. Just need to check how many times what is the minimum time I need to refill. Yeah. Basically for my function, I need to use the start fill to check if it is less than the target. Yeah, because if the start fill has already been more than or equal to the target, I don't even need to check. I just need to return 0 because there's no need to refill. Yeah. Now I need a second loop to check to put the oils, to put the gas, to put the quantities of the gas inside my max heap. Yeah, basically I need a max heap because I want to find the maximum number of the maximum volume of the gas or maximum liter of the gas. Yeah. So I also needed to prepare a position I as my index. So this I would also be start as 0. Yeah. And also I needed to prepare a max heap as an empty array. Now I can start to check. So if I is less than the length of the stations, so this means I want to check from the stations how many stations I can go through with the first start field. Yeah. Now I need to check with this start field. So if stations, yeah, so if stations I 0 less than, let me check. If the stations I are 0 less than or equal to the start field. Yeah, so for example, the first one, the station I0, it means station 0, 0, it means it's this 10. If this 10 is less than or equal to start field, to this number, this 10, it means I can put it inside my max heap. Yeah. Now I can put it inside it, so I can use heappush with max heap and with this number. So the numbers inside is the gas inside is the stations with I1. I also need a negative value because in Python there's no min heap. So if I were to use a max heap, I have to use a negative value. And later on, I also gonna use a negative value. I just need to turn it to a positive value. Yeah. And I can also be updated to 1 because I want to check 1 by 1 until this stations I0 is more than the start field. For example, until this 20 is more than this 10, I'll stop my while loop. Yeah. Now I can update my result by 1. But before update my result, I have to check. Yeah, I have to, if I want to update my result, it means I have a refill. So I have to prepare the refill. So what is the refill? So refill is the start field plus equal to the heappop. Yeah, I should heappop from the max heap. Since inside the max heap, it is always be negative values of the gas. So from here, I need to give a negative value, right? So from here, I can change it to negative and put here to positive. Yeah. So this just means my start field will always be increased. So from 10, it will become plus 60. It will become 70. Yeah. Now, so this is basically the entire code. But we also need to check if, for example, if let me check. So if the target, for example, is 200, yeah, if this target is 200, no matter how much refill we can get, we can never go to the target. So for example, this is 60 plus 30 plus the start, it is 100 plus 30 and plus 40, it is 170. But our target is 200. We can never reach it, even we refill at each station. So we have to check. Yeah. So if it go out of the while loop, yeah. So before the start fill plus the maximum of the gas, we have to check the max heap. Yeah. If not max heap, it means there's no gas inside the max heap. I have to return a -1. So this means I didn't even, yeah. So this means even I, yeah. So this means even I refill, but I cannot reach to the target. So if the max heap becomes empty, it means, yeah. So this means for the start field, I gonna plus the max heap. So for the next loop, I didn't put anything inside. So I still, yeah. I still do a refill, and then I still do a refill. After finishing all those refills, I didn't go out of the loop. Why? Because my start fuel is still less than the target. So inside the loop, I need to have a tag. So if not max heap, I'm gonna return a -1. But at which position I need to prepare this line? Yeah. So for here, we are going to pop it out from the max heap. Yeah. So before it, we need to check if it is not empty. Otherwise, we cannot even pop it out. And from here, we put everything inside the max heap. Yeah, let me just run it to check if it works. Yeah, as you can see, it works. But can we put it here? I mean, can we put it here? No, we cannot. Because when we put it here, for this loop, yeah, I think so. We can still put it here. Let me have a try. I think we can put it here or there. It should be, yeah, we cannot. Yeah, we cannot put it here because if we put it here, it means we checked too early. Even the max heap is empty, it doesn't matter because from the beginning the max heap is empty. We cannot return a -1 immediately. So we have to check for the inner while loop. Yeah, we have to check the possibilities whether we can put something inside the max heap. If we cannot put something inside, it means the max heap is empty. We cannot even use a refill. Yeah, so we need to return a -1. Otherwise, we cannot stop the loop. So how should we stop the loop? We're gonna use this line to stop the loop. Just means it's gonna return a -1. It means even we take all the gas from all the stations, we cannot reach the target. So we're gonna return a -1. Otherwise, our result should +1, and the start fuel should plus the refill value. So this is the refill value. Finally, we're just gonna return the result. And for this question, we cannot even use the sort because the position of the stations are fixed. We cannot sort it, but we can use max heap to check. Yeah, we can take the maximum quantities of the gas. Yeah, when we need to, when we hold all the possible solutions, we always choose with the maximum quantities of the gas. Yeah, now let me submit it. Yeah, as you can see, it passed and it's pretty fast. Now let's analyze the time complexity a little bit. So for the time complexity, we have the start fuel, and the start fuel should be less than the target. So this is just a while check. But inside, we're gonna loop through the stations one by one and check if it is less than or equal to the fuel. And inside, we're gonna use the heappush or heappop. But basically, the heappush or heappop, it is just O1. So the main calculation is coming from here. Yeah. So the I less than the length of the stations. We need to check the length of the stations basically. So what is the length of the stations? So it is 500. Yeah, so there are only 500 of the stations, and this one is just a value to check. Yeah, so basically it is also ON. N is 100, I think. Yeah, because the main calculation is coming from here. We just need to check one by one and put it inside the heap. If we put it inside the heap, it is just a O1 calculation. Even we take it out, it is also O1 calculation. Yeah, so all the calculations only concerns with the stations array. We just need to put everything inside and take one out, and then put another inside and take one out. So this is why the time complexity